Our class, we're going to talk about simple machines, inclined plane, wedge, and screw. And here's our examples. We briefly mentioned them in our last lesson, but we really did not get into much in depth on them. So we're going to go into them a little bit more here. Just a recap of the definitions. We're looking at the magnitude of resistance and effort forces and the distance traveled by effort and resistance forces. Short little example. What is an advantage of 4 to 1? Tell us about a mechanism. Basically, effort force magnitude is 4 times less than the magnitude of resistance force, and distance traveled, effort force travels 4 times greater distance than the resistance force, and the effort force in this animation is the red arrows, and the resistance is the blue arrows. All right, to recap from our last lesson, MA greater than 1 makes it easier to use, MA less than 1 makes it more difficult to use. And MA can never be less than or equal to 0. All right, so IMA deals with distance. Here's our formula. I'll have that, keep that up on the right-hand side there throughout this lesson. And AMA deals with force. And AMA is the one where we look at friction, and the IMA is not. Friction is not taken into consideration. All right, so an inclined plane is a flat surface at an angle or inclined with no moving parts. The only thing that moves is the effort and resistance, and the inclined plane stays stationary. All right, inclined plane IMA. Distance effort goes along the L plane. Distance resistance goes along the H plane. And so IMA equals L, which is the slope. And that's going to be 15 feet. H is the resistance, and that's going to be 4. So it's going to be 15 divided by 4, which is 3.8 to 1. What is the AMA? Force resistance is going to be H, and force effort is going to be L. So if you look at this, you have the force resistance is the 50 pounds. That's going on top. So the 50 pounds is traveling along the H plane, and the 20 pounds and the effort is going along the L plane. So it's going to be 50 divided by 20, which is 2.5 to 1. Efficiency is AMA over IMA. AMA is 2.5 divided by 3.75 times 100, which is 67%. All right, wedge functions as a moving inclined plane. Tapers to within an inch and is used for splitting, raising heavy objects, or tightening by being driven into something. Wedge, IMA. IMA deals with distance. So L is your effort. H is your resistance. And so it's going to be 10 divided by 3, which is 3.3 to 1 on the ratio. AMA deals with force. So the 700 by my mouse, this is going along the H plane. 250 is going along the L, so it's going to be force resistance is going to be 700 divided by 250. Pound units of measure in pounds cancel out, so it's in 2.80 to 1. And efficiency is 2.8 divided by 3.3 times 100 equals 84%. All right, so this is going to have a very low mechanical advantage or efficiency. Inclined plane wrapped around a cylinder forming path and pitch. Wheel and axle used to create rotary motion. So we're changing rotary motion to linear. So as the screws turn, it's going to lift up in a linear motion. It's a large mechanical advantage. And a large amount of friction loss. Okay, so that's going to be important because you want these things to hold things together, so you want a large amount of friction. All right, so effort distance from the center of the bolt to the edge is the arm distance, the pitch. There's your pitch. One rotation of the screw. There's your pitch right there. And then you're gonna have to read. This is how it's stamped into the bolt or the box that it comes in. They all come in. It's going to have these numbers. This is the diameter, ½ inch, threads per inch, 13. And down here it asks if 13 threads per inch, then pitch is 1/13 of an inch. Okay. How far will a screw with 13 threads per inch move linearly if turned in one motion? 1/13 of an inch. Okay. All right. So IMA is effort over resistance, and the effort is the circumference. Resistance is the pitch. Okay. Remember, pitch was, I believe, 1/13, and circumference is 2 pi r. So, looking at an 8-inch long wrench, that's my radius. So, because the wrench goes from the center of the bolt out to the end of the wrench, and so we're going to go 2 pi r, which is 2 times 3.14 times 8 divided by 1/20th. Oh, my pitch in this one is 20th. The bolt in the previous was 13, so I mixed those numbers up and got them, at least I got them fixed in this time. All right, so result comes out to be 1005.31, and I'm not going to have, in this course, I'm not going to have you go to convert that out to scientific notation. We're just going to go to this step, and we'll end it there. 1005.31. So the AMA is resistance over effort, and my effort is 35 pounds, and my resistance is 1,200 pounds. And so, what is the AMA of the screw above? 1,200 divided by 35 is 34. Efficiency is AMA, which is 34 divided by 1005.3 times 100 is 3.4. And so the efficiency, the lower the efficiency means that in this case it's going to keep the two pieces of material that you fasten together with that bolt. It's going to be inefficient as a machine because of the increased friction, and the increased friction slows everything down, which keeps those two pieces of material fastened together. So you want a bolt with a low efficiency rating. All right, so compound machines, simple machines working in combination to complete a task calculating mechanical advantage, MA total. So you have multiple simple machines in a bike, for example, working together. You got levers, you got sprockets and chains and all kinds of things working together, wheels. So calculating the total mechanical advantage of each component of a bike, and you multiply those out, and that gives you your MA total. All right, so that is incline planes and screws and wedges. And so hopefully these two lesson video tutorials will help you out with the activities we have in the Google Classroom. If you have any questions, contact me through Google Classroom, and see you in the next video.